Once we get down to the motor, we have 4 flange bolts, like we see right here, that must be loosened. At that point, we then lift the motor up, take the old belt off, and replace it with the new belt. Once the new belt is in place, directly below the motor is a tensioning bolt. This is required to increase the tension on the belt because the weight of the motor is not enough to tension the belt. Then we tighten our flange bolts back up again, and making sure to replace our safety cover. That keeps all the sawdust from building up inside the belt area. What we're looking at now is the motor for the right and left vertical spindle. It is located right here in this position. By the way, this rod is holding up our dust collection and is not part of the machine. Directly below the motor we have our belt assembly, and this has no cover on it, so that nothing else needs to be removed when we replace the belt. As we go to the right side of the motor, you'll notice 2 screws which hold the motor to the support bracket, and behind the 2 screws we have another adjustment screw. This is the screw we use to tension the belts. As we work our way down to the outfeed end of the machine, the next motor in line is the motor for the top horizontal spindle. It is very similar in design as the first bottom head, in that we have a safety cover covering the belt, 2 screws holding the safety cover in place, the 4 type of flange bolts to loosen the motor in order to remove the old belt and replace the new belt, and also underneath the motor the belt tensioning bolt. As we move closer in, you can see some grease fittings here, and we'll give you a view of one. There's a total of grease fittings for all the slides related to the top horizontal head, 3 at the top and 3 at the bottom. Make sure you see all those grease fittings and you grease them regularly. The last spindle motor we're going to talk about is for the last bottom head. It's similar to the other horizontal heads in that it has a safety cover with 2 screws securing it, 4 flange bolts to loosen the motor in order to get the old belt off and the new belt replaced, and directly behind the motor we have additional grease fittings. The last bottom head has 1 grease fitting on the left side and 2 more grease fittings on the right side. As we move to the bottom of the head, we can show you the adjusting screw, which is the same on all the other horizontal heads. Here we attached a piece of tape to the back of the screw in order for you to see it better. This screw has a jam nut at the top which needs to be loosened, and then we can increase or decrease this screw depending on whether we want to increase or decrease the tension on the belt. Then we tighten the jam nut. Directly below the motor for the top horizontal head, you'll notice we have 2 lifting motors. The one on the left is the lifting motor for the feed system. The one on the right is the lifting motor for the top horizontal head itself. Directly behind and above the motors, we have the lifting screws. It's important that we keep these lifting screws lubricated and clean. At the base of the lifting screws, you'll notice we have 2 grease fittings, the one on the left and the one on the right. These need to be maintained like all the other grease fittings on the machine once every 2 weeks. Directly above the spindle drive motors, you'll notice we have the gearboxes for the feed system. This machine is equipped with 3 gearboxes, one that we see here on the outfeed end of the machine, one towards the center of the machine, and one more on the infeed end of the machine directly underneath the feed motor. As we look closer, we'll see a sight glass and a fill plug. The only maintenance required for these gearboxes is we watch the sight glass. Once the level drops below the center line, then we take the gear plug out and we add more gear lube. While we're talking about the gearbox, here's another shot of the gearbox. But what we're trying to show you here is towards the front of the machine, we have a secondary gearbox. This gearbox has a grease fitting that you can see right here, and that needs to be maintained like all the other grease fittings once every 2 weeks. This shot here is showing the gearbox on the outfeed end of the machine. Directly below that, we have the power-driven roller below the table on the outfeed end of the machine. From time to time, that needs to be adjusted. The way we adjust that is from the front of the machine. But what we wanted to show you is what the screw looks like with the jam nut. We highlighted that bolt for better viewing, and your adjustments are made from the front by loosening the jam nut and turning the Allen screw to raise or lower the roller. The roller of the table should always be about 5 thousandths higher than the table itself. Since we talked about the maintenance in the back of the machine, let's now talk about the maintenance on the front side of the machine. Aside from the obvious where we need to blow off all the excess sawdust, we have several grease fittings like we see here throughout the front of the machine. This one is on the outfeed shoe, and there's another one exactly on the opposite side between the outfeed shoe and the molder. As we move towards the infeed part of the molder, we have one more grease fitting here directly below the top horizontal head. Exactly opposite here, around the left head, we have two more grease fittings. And then directly below the digital readout that we have here for the left head, we have a fitting here and another one right next to it. We have a total of 7 fittings on the front of the machine that need to be greased once every 2 weeks. We're now at the back of the Superset 23. Let's take a few minutes and talk about the electrical controls. First, we have to open our electrical cabinet. We do that by loosening the locks and then shutting the power off at the machine. The machine is equipped with an interlock which prevents us from opening the door while the master switch is turned on. Once inside the cabinet, you'll see that we have the incoming power supply on the bottom of the machine and on the right side of the cabinet. Those wires then get connected to this junction block. Keep in mind though, even though the power is off, the incoming wires are still live. So anytime we want to do any kind of maintenance work inside this machine, it's a good idea to shut the power off at the breaker box. Another feature this machine has is that all of the circuit breakers here are interlocked, meaning that if one single circuit breaker anywhere in the system should blow, the entire machine goes dead. So if you find that your machine will not start and nothing will be activated, it's a good idea to go to the back of the cabinet and check the breakers. The push-button breakers will look like this when it's disengaged. All we have to do is push the black button back in. And the flip breakers will turn sideways in relationship to all the other ones. Once the breakers are reset, the machine should start properly. Now we're going to take a few minutes and talk about the feed wheels. As you can see, we have 2 shaft-mounted wheels, and here we have 2 flange-mounted wheels. The machine comes with extra wheels for different types of applications. Here we have a shaft-mounted wheel that's 1 inch wide to work together with our 2-inch wheel. And here we have additional flange mount wheels that are also 1 inch wide. If we want to reposition the wheels, what we do is take our 13mm wrench, loosen the nut, and now the wheel will slide up and down the entire length of the shaft. If we're going to feed wide boards, we're going to want to put 1 additional wheel and leave this at the extreme end, giving us good positive hold downs on both ends of the board. It's a little bit different with the flange mount wheels. With the flange mount wheels, we stack the wheels one on top of the other, and then we bolt them down. If we want even wider spacing, the machine comes with 2 spacers, which we'll put between the feed wheel, and then we'll use a longer bolt, allowing for wider spacer and more positive hold down. For the best in feedability, we want to have as much contact with the wood, with the feed wheel, as possible. The other thing to keep in mind, we have to make sure of the direction of the feed wheel. We want the edges of the feed wheel digging into the wood and pushing it forward. Located on the side panel at the outfeed end of the Superset 23 is another SCMI exclusive, the mobile control. This control is great for setup work because it allows me to feed forward or reverse or raise and lower the entire feed system, including the cutter head. Also, I have an emergency stop button here, which is great for safety. I can kill the machine at any point, anytime. Let's take a few minutes and talk about troubleshooting. The area we're going to talk about first is feeding the molder. It's a common problem with molders for boards to get jammed up, but most of those problems can be solved quickly and easily. We'll talk about all the pressure points and what's required to get those pressure points relieved. Keep in mind though, some boards are just going to have problems being fed. Boards that take severe profiles, boards that are very thin in relationship to their final finish size, these things are going to be inherent problems that you're going to have to deal with. But for the most part, most of the feeding problems can be taken care of easily. As you can see, we have a board in place underneath the feed wheels, and we're going to let the feed wheels push the boards through, but we're not going to have any of the cutter heads running. So let's advance the board, and you can see here now our first problem point. This is going to be the chip breaker. As the board comes through here, it moves the chip breaker back a little bit, and we have to make sure that there's still additional movement beyond the board. If there isn't, it's probably pinching the board, and it could stop the board from moving. If we need to make those adjustments, they'll be done with these 2 screws. This screw here limits the outward movement of the chip breaker, and the screw right next to it will limit the inward movement of the chip breaker. Directly below it, we have a knurled knob, as you can see here, and this adjusts the amount of pressure that's being exerted by the chip breaker. These adjustments will usually take care of the problems that are associated with chip breaker binding. One more thing to add here, if you are checking and you are increasing the back movement of this, make sure that you still have clearance between the chip breaker and the knife. As we continue with our board, the next area is going to be the pneumatic chip breaker just before the top horizontal head. If we have too much pressure here, again, it'll pinch the board and prevent it from coming through the machine. This can be easily taken care of by going to our pneumatic regulator and decreasing the pressure on the pneumatic chip breaker. Another area in this general vicinity is going to be the fence. If the fence isn't set properly against the wood, it'll also pinch the board and prevent it from feeding through the machine. Along the side here, we have 2 sets of screws which will allow us to move the fence in and out for additional clearance, and 2 more screws which allow us to raise and lower the fence as necessary. Now, continuing down the line, the next area that's considered a pinch point is going to be the outfeed pressure shoe. This can easily be resolved as well with the control knob on the top. The black knob will raise and lower the outfeed pressure shoe, giving us clearance. The knob just below that, or the nut just below that, will increase or decrease the amount of pressure being exerted on the shoe. Now, as the board comes through, we can see here that if everything is set properly, the board should, in most cases, feed through the machine without hesitation. You can see we have no pinch points at this point, and the board comes through without any problem. Let's take a few minutes and talk about a condition called sniping. That's where we have slight imperfections at the extreme ends of the boards. Now, these are problems that are prone to all molders, but these are problems that can be overcome if you know where to go. Let's talk about some solutions. When we're looking at the molder, the first head that's going to create sniping is going to be the bottom head, and that'll always create our sniping on the bottom side of the board. If our snipe occurs on the infeed portion of our board, that means that this bottom head is too high in relationship to the outfeed table. If our sniping occurs on the bottom side trailing edge of the board, that means that the outfeed bottom head is too low in relationship to the outfeed table. The next area for concern is going to be the right side of the board. If our sniping is on the leading edge of the right side, the same thing will be true with the right head. The right head is too far forward of the outfeed fence. If the sniping is occurring on the trailing side of the right side, then the head is too far inward in relationship to the outfeed fence. Now, this one's a little bit tricky because we also have one more condition that can cause sniping that'll be on the first bottom head, and that's the alignment of the reference engraver to the reference fence. If that's not aligned perfectly, all the adjustments in the world on the right head will not eliminate the sniping. The final area for sniping is going to be on the top of the board, and usually that's the most critical one because this is where our profile is going to be. If we have a sniping condition on the leading edge of the board on top, that's always caused by the chip breakers. Not enough chip breaker pressure will allow the board to be lifted as it's being machined, creating the sniping condition. This is easily solved by going back to our control panel and increasing the pressure on the chip breaker. If we start developing a snipe on the trailing edge of the board, that's going to be the outfeed shoe. Again, once the board is passing through and released by the front chip breaker, we have a length of wood that's unsupported. As it goes through the machine, it gets lifted by the forces generated by the cutter head and creates a snipe at the end. Increasing the pressure on the outfeed shoe generally will hold the board down and eliminate the sniping. Let's take a few minutes to talk about the placement of the molder in your shop. There's a number of considerations that have to be taken when placing the molder in your shop. One might be how long the longest board is going to be that you run through your machine. In most cases, that's 16 feet. So we need to consider how much space we'll need on the infeed and outfeed end to accomplish that. The other thing will be, if we're placing the machine close to a wall, how much space do we need between the wall and the machine? Generally, it's a minimum of 3 feet. This will allow us to get in there to do any kind of service or maintenance work should it arise. Another consideration is going to be dust collection. The machine requires 3,450 CFM